In 2-3, we're going to start putting some of the algebra back in with our geometry again. Okay, we've gotten through some of the algebra at the start of the chapter like we always do for this class. And now back to the geometry. So we still need to look at one theorem first, the triangle sum theorem. And that says that all angles, which in a triangle there would be 3 of them, all angles in a triangle, which I'll just draw a triangle, add up to 180 degrees. Okay, triangle sum theorem. All of them add up to 180 degrees. Okay, so then you know you have to come up with an equation, show all of your work, and so on and so forth for all of these. So in number 1, the 3 angles I see are 61 plus 83 plus x. Those all 3 have to add up to 180. If we combine like terms, I'd have x plus 61 and 84 is 144. From here, we'd be subtracting 144. And x would equal 36. Think about what we've done before. X is an angle. It's standing alone in the picture. Therefore, it does need to be degrees. Okay, so we'll go ahead and box that. All right, 2 wants us to find x, but it actually asks us to find angle A. Okay, so we want to make sure we're always answering the question. So technically it doesn't ask us to find x, but we've got to find it first. So here we go. I see 2x plus 9 as one of the angles. I'll add that to 4x plus 3 and plus the third angle of 2x. All 3 of those have to add up to 180. All right, so combining like terms, we have 8x's plus 9 and 3 will give us 12. If we subtract 12 from both sides, 8x would equal 168. Divide by 8 on both sides, and x will equal 21. So notice x does not stand alone. So if I was asking you for x, I would just be asking you to tell me x equals regular 21. Remember, this problem is really asking you to find angle A. Okay, that was the question given to us there. And therefore, you're going to show that work and tell me that angle A equals, well, angle A is up there where it says 2x plus 9. Okay, and so you're going to say 2 times the 21 for the x plus the 9. Order of operations says multiply first. So if you did like 2 times 21, if it was tougher on your calculator and push equal and then plus 9 and push equal again, you would get 51. And angle A is an angle, so it does need to be degrees. Okay, there's exactly the work for 1 and 2. Next, if we are going back to our parallel lines crossed by a transversal, and we're supposed to find all the angles in the figure. So now here's where it comes into play of you really got to know your types of angles, okay, that we were doing at the start of this chapter. So notice 1, arrows. That means those lines are parallel. So now our 4 types of angles, alternate interior, alternate exterior, corresponding, and vertical are all equal to each other, okay, versus just vertical is always equal to each other. So I look at these and say, are these expressions where they're sitting, are these angles, the 5x plus 15 and the 7x minus 25, are they one of our new types of angles? Are they? Well, I hope you're thinking that where this is lying, this and this would be corresponding angles, and therefore they are equal. Okay, so the equation we're looking for is for you to tell me 7x minus 25 equals 5x plus 15. Okay, it would not matter if you told me 5x plus 15 equals 7x minus 25. That doesn't matter, right? Like 3 equals 3 doesn't matter if it said 3 equals 3. They can flip sides. I'm just thinking ahead. I want my bigger x on the left. okay, because most of you like positive x's. I want you to get in the habit of making the equation and writing down y. So next to it, it can be as simple as you just putting CA. Those were corresponding angles, and corresponding angles are equal if the lines are parallel. All right, and then showing your work, if we subtract 5x from both sides, right, those are gone. So 2x minus 25 equals 15. Add 25, add 25. This is gone. 2x will equal 40. And if we divide by 2, x will equal 20. Okay, now I look at the picture itself. It doesn't stand by itself, so x is just a regular 20. But then I do need to follow those directions. Notice the word all. Find all angles. Okay, we've talked about that before. So remember, guys, and I might also be asking you in some of the homework questions to label the transversal. So it's as simple as you can just label that with the T. Okay, so put an arrow to it. That is your transversal. And now we're ready to plug in the 20. Okay, since those are all equal, then how about I just show you 5 times 20 in parentheses plus 15. So 5 times 20 push equals plus 15 push equals will give you 115 degrees for that angle. Okay, so if this is 115 and you went through and you marked all the angles that were equal, I hope you would mark those appropriate for with the appropriate mark. Okay, so all of these are 115 degrees. And all of the other ones should be 180 minus 115. So I hope you're getting that these would all be 65 degrees. Okay, because these, if I just use a different marking, I'll just use a dot, all 4 of those would be equal to one another. Okay. All right, next problem. I hope you are seeing 1. Parallel lines, right? Because of those 2 arrows. That means I want to know if the 5x plus 2 and the 3x plus 10 are one of our new type of 4 triangles, or sorry, angles. And right now I cannot see that they are. Okay. Think through your different types. I cannot see that they are any of those. However, because of the parallel lines, I could target any of them. Okay, it doesn't matter which one. I'm just going to target the 3x plus 10, and I'm going to put some marks. I know that 3x plus 10 is equal there, and here, and here, which means I could pick up 3x plus 10 and write it in any one of those 4 spots. Well, I'm going to put it in a convenient spot so that it's near the 5x plus 2, and I can see the relationship. Okay, and I hope the relationship that you are able to see is that these are now next to each other, and therefore they are supplementary. Okay, so I hope you're ready to tell me that 5x plus 2 plus 3x plus 10 equals 180. Okay, remember every set of angles, either one of those 4 types that we learned new this chapter or supplementary from last chapter. Combining like terms, we have 8x plus 12 equals 180. And guys, I'll leave it up to you. If you still need to keep doing all of this work, like over here, okay, to get things right, do it. I don't care if you do that for the entire year. But at this point, if you're starting to be pretty good at your algebra, okay, and you can just verbally say at this point, subtract 12 from both sides, which leaves you with 8x equals 168. And if you can now say divide by 8 on both sides, which gives you x equals 21. If you can do that and show, that's the minimum number of steps you should be showing. Okay, that's the minimum number of steps you need to show me to get credit. But if you can do that and get it right every single time, I will let you stop showing me all of these steps. Okay, if you ever start making mistakes, careless mistakes, and getting them wrong because you're not showing that, then go back to it. Okay, there's no shame in it. I would rather have you get it correct. Okay. All right, so then if x is 21, it doesn't stand alone. Again, we're into that mode of we're supposed to show every angle. All right, so I will just do 3 times 21. I'm using like the 3x plus 10 above. 3 times 21 plus 10. Order of operations, 3 times 21 push equals plus 10 push equals, if you're using your calculator, would give us a 73-degree angle. Okay, so that means the 73-degree angles are everywhere we had those marked the same. So 73 degrees. And I hope the other 4 would be their supplements. So you should have 107 degrees in the other 4 angles. Okay, just make sure again that you've done all of them and all 8 of them are labeled. Okay. All right, next, number 5. Okay. Here's the biggest mistake students make. They'll try to come up with an equation for me, and they'll tell me 8x equals 10x. Right? Because they're alternate interior angles. Agreed? Think about it. I do agree that 8x and 10x are alternate interior angles. However, please notice there are no arrows here, right? Those are not there. Nor did anybody tell me that the 2 lines that are cut by this transversal right here are parallel, and therefore I cannot assume they are parallel. Okay, so don't make that mistake. All right, that means the only thing I can do then is go with these 2, and that's because they happen to be on an X or a V, whatever you want to call that. The only thing I can do is talk about vertical angles. Vertical angles are always equal. Therefore, my equation needs to be 8x equals 100. Again, you should be telling me that's a vertical angle. On that note, did we do that back here? Nope, but we should have. Okay. Back here, our one on the right, we should have said that these are equal to 180 because they are supplementary angles. I think that will help you practice for this chapter's tests. Okay. All right, so anyway, if 8x equals 100 and you divide both sides by 8, then x will equal, now it's a decimal, but it's a nice decimal that ends, remember? So we said we will take nice decimals that end. So 12.5 is fine. And if I was to go now and plug in x to solve for all of my angles, well, then here we go. We are ready to say now that 8 times 12.5 better be 100 degrees, right? Because they were vertical, they were supposed to be marked equal. If we do its supplement, this better be 80 degrees. This better be 80 degrees. But now I'm going to come down to the 10x and plug in 10 times 12.5, making this angle 125 degrees. Its vertical angle 125 degrees. And then both of their supplements, 180 minus that, would be 55 degrees. Okay. Okay. Next. System of equations. All right. Well, I was nice this time and told you this is a system of equations. In the future, I would not. How are you supposed to know that this is going to be a system of equations? Well, the tip-off should be I see x and y in every expression. Okay, so if you've got more than one variable, it's going to end up being a system of equations. We told you this is going to happen all year long. So here we go. I would like you to come up with all 3 equations. Okay, I know for a system you only need 2, but we need to practice with this. So there are always 3 equations to come up with in most of the pictures that we give you. So let's first ask you for these 2. What's the relationship between this angle and this angle? I hope you're going to tell me that they are equal because they're vertical. So here's one equation. 6x plus 2y equals 4x plus 3y. Okay, because they are vertical angles. All right, next, let's go with what's your relationship between this one? Again, I'm just going to use dots. I'm not trying to mark them equal. I'm just trying to ask you. This angle and this angle. Well, I hope you're thinking it's not one of your new ones, but that if you picked up this 5x plus y plus 10, so I'll use a different marking now, and you moved it anywhere it is equal, because of these parallel lines, right, because of the arrows, I could say that 5x plus y plus 10 could be written in any one of those 4 spots. So why don't I put it in a convenient place, 5x plus y plus 10, to be able to visually see that relationship between that and the 6x plus 2y that I asked you about. And I hope you're going to notice that they are right next to each other, and therefore they would be supplementary and add to 180. So we will say that 6x plus 2y plus the 5x plus y plus 10 will also equal 180. And that's because they are supplementary. Okay, and you can always just abbreviate that as sup for me. All right, and then the last one, let's ask you, what's the relationship then between this one, the 4x plus 3y, and the 5x plus y plus 10? Well, I hope you're going to notice you already moved it here, and therefore, again, not using the dot to tell you that they are equal, but I hope you're going to tell me that they are next to each other, and therefore, these ones are supplementary. Okay, so now you would be telling me that 4x plus 3y plus 5x plus y plus 10 equals 180 because those are supplementary. Those are the types of equations you need to be able to come up with from a picture. Okay. Now, remember, you've got 2 variables. So for a system, if you've got 2 variables, you need 2 equations. If you had 3 variables, you would need 3 equations. I made you come up with the equations for practice, but in reality, you need 2 of these equations. Okay. So I'm going to say, when it's on your paper, pick any 2. All right. You get to pick the 2 that you like. I try to use the most obvious ones, which what I mean by obvious isn't that it's simple. I mean that they're the ones that usually I don't have to pick up and move something. In this case, I had to, no matter what I did. Okay, so I will just tell you that I'm going to pick the top 2. Okay, I'll just go with the top 2. But I'm going to do some manipulation and line them up because remember, I like to do elimination. So here we go. On that top equation that's in purple, I want to manipulate it so my x and y are on the same side, and I have a constant on the right side. Okay, so if I subtract 4x from both sides, so the x is on the left, and I also subtract 3y from both sides, so that the y's are on the same side, let's clean that up and bring it down. So the 6x minus 4x is 2x. 2y minus 3y is negative y. And guys, what's left on the right-hand side? Well, if this cancels and this cancels, you're left with 0. 0 is a number. Be comfortable with that. Okay, that always seems to mess people up. All right, I'm going to now manipulate the middle one. Same thing. I want my x's and y's on the same side. Well, I noticed they already are. I just need to combine like terms. So 6x and 5x is going to be 11x. 2y and y is going to be 3y. And then I need to manipulate because I want my constant on the right-hand side. I'll subtract 10 from both sides. And now it will equal 170. All right, I completely cleaned up those 2 equations so that they look the way I like. Okay, for a system of equations, remember 99.9% of the time, Miss Barber always does elimination because that's what I like. So your question at this point to yourself is, if you were to add straight down, does one of the variables get eliminated? And I hope you're going to tell me no. But I hope you also notice that if you were to multiply the top one by, what could I multiply the top one by to get the y's to cancel? That's the easiest one. I hope you're going to tell me 3, right? So now if I continue on, that top one with the distributing the 3 is going to be 3 times 2x is 6x. 3 times negative y is going to be negative 3y. And 3 times 0 is 0. The second one always just gets recopied under it, okay, to keep them in the same order. Draw that line. If I add straight down, does a variable get eliminated? Yes, it does. That was the whole point, right? Those go away. And therefore, 11 and 6 is going to give us 17 x's equals 170. If we divide by 17 and you don't need to write that anymore and can get it right, then fine. X would equal 10. Okay, if you pick that up and plug it back in somewhere, I'm going to go there because that's a smaller number. Show that work. Then 2 times 10 in parentheses minus y equals 0. That's going to tell me 20 equals. Probably easiest to just add y to both sides, and you'll have y equals 20. So that ordered pair would be, x comes before y, it would be 10, comma, 20. There would be your final answer. Okay. Keep trying to identify and come up with those equations on your own. Keep practicing that, and definitely keep practicing those systems of equations.